All right, for example 2, we're going to verify the identity, which means we start with what's on the left, and I have to move it to what's on the right. One hint when you see two binomials is a strategy that I talked about in the front with foiling. Another hint I have is when you have a trig function squared and a 1 combined like this, in both of these cases, often it will be a Pythagorean identity because all of these have 1s and squared trig functions involved. So I'm going to look here and see 1 plus tangent squared of u equals secant squared of u. That's what I have here. So I'm going to sub out this for secant squared of x. Here, cosine squared of x minus 1 is not this one exactly, but if I were to take the 1 and subtract it over, and then take the sine squared of u and subtract it over here, I would have that. So I can say that cosine squared of u minus 1 equals negative sine squared of x. It's my first substitutions. After that, I'm going to use the reciprocal identities. Although they're not squared here, you can use squared versions of all of them. So secant squared of u equals 1 over cosine squared of u. You just square both of the trig functions and you can use them. So that would be 1 over cosine squared of u for x. Next, I'm not going to do anything. I'm not going to do any substitutions. I'm just going to combine these by writing them in one fraction. And then last, I have my quotient identity. When you have a sine on top and a cosine on the bottom, like you have here, even when they're squared, you can sub that out for tangent. So this would have the negative in front, and then it would be tangent squared of x. That's what I was looking for, so I'm done.